Hey guys, this is Mr. Riz, and I'm here to help you with the 212 part two. It's your turn. I have the 212 part one with all the code here that's going through, and we're going to use this to help us out. We might want to go ahead and we might make some more additional RIPL files. We'll kind of play around with this because it has so many different PY files, but we're going to use this in part two. So what we're going to do now is look at it's our turn. We've learned to kind of look at decrypted messages. We've learned how to take a message and encrypt it. We guess we didn't decrypt a message here. Let's see if I can do one real quick. So let's encrypt one first. Encrypt. And I'm just going to encrypt a message here. I'll just say go Gales. I'll shift that 5. 5's the number. Okay, can I copy paste this? Control C. Oh, that won't let me. All right, so really, can I paste it like anywhere down here? Nope, that's the link to the YouTube video. Okay, I'm just gonna write it as a string then. LT LFQJX. Okay. So that shouldn't mess with anything here because it's separate. Let's rerun this file now just to show you. All right, let's decrypt. Enter the message LT LFQJX. And if we know the number, our secret key was 5. It says go Gales. Okay, so we can kind of decrypt and encrypt. It's a little messy using RIPL here. So if you have a different, or maybe if I pull up the shell, maybe that can we copy paste it in the shell? LT LFQJX. Yeah, Control C. Oh no, that won't let me work. Okay, so we'll kind of have to mess around with the code editor here in order to save some files here or save some text. All right, so let's look at the frequency analysis from before. If we remember, the most common letters were E, T, and A. So the English language conventions to solve a popular problem known as a cryptogram. You might have seen these like in the newspaper back in the day. So a cryptogram is a type of puzzle that consists of a short piece of encrypted text. The cryptograms use substitution ciphers where each letter is replaced by a different letter. And to solve the cryptogram, you must recover the original letter. So this is not just a slide, but this is where every single letter is replaced. So let's look at this code here. And you know what I'm going to do? Let's see if we can just copy paste this. Control C. I'm just going to paste this into a string. And you know what? We could probably save this as a variable too, like secret message equals. There we go. Probably we'll use that later on. All right, so we could go ahead and write this out on a piece of paper, or maybe jot some things down, or a spreadsheet if you want, and look at all the letters in the alphabet. We're going to try to go through and see what would this mean, and we'll use this as some reference later on. So we can copy paste this. So hopefully you guys know the Control C, Control P, and we're going to get this message here. So let's run a frequency program that we've downloaded here to figure out, okay, how many there are. Now, I guess you could just count this up, but we have a frequency program already used. The problem is if we try to run the frequency program in RIPL, it just kind of like goes through and it will always run the main PY file. So I guess what we could do, a couple different things. We could rename this as main PY maybe. Actually, no, what we need to do is we can't rename this. So let's copy paste this, Control A, Control C. We're going to copy this. And then after we run like a decryption, I'm going to just put this here. So this is kind of cheating, but this will work just for RIPL. So what's going to happen is we're going to run our encryption decryption code here. And then after that gets run, we'll have our secret message here and go through. So if we just run this now, let's run this again. It says, okay, ask us to, let's just encrypt something. I think we can just type E. I can type in a message. What's up? Shift it over 25 spots. There we go. Okay, now it says enter a string to analyze. All right, we could type in all the secret message, but what we could do here, if we kind of cheat, if we look at our code here where it says phrase equals input, if I just say phrase equals secret message, it's not going to ask me to type anything in. It's just going to automatically do that here. All right, so let's go ahead and run this. We got to do encrypt, whatever, yada, 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 enter the number. Okay. So now here we go. It actually went through our secret message and count the letters and returned that all here. It's using a dictionary, which we don't really need to know too much about, but we can see it. Y is very common. It appears 20 times. Anything else? Ooh, a space appears 50 times, which makes sense. I mean, there's spaces. That's not a letter. That's not going to change at all. So let's go ahead and maybe write this list down or kind of keep this off to the side here. All right, which letters are used most frequency? Which letter occurs most frequency? I think we can all assume that the letter Y occurs most frequently, which is the second most frequent. Q. Okay, so how could we use this information to decrypt message? Well, we pretty much know that the most common letter used is E. So we might want to replace all the Y's with E. The second most common would be T or A. So even though like Y is E, we might want to start looking through the message here and be like, okay, Y is the most common, but if I start replacing all my Y's with E, I would have just a random E. So probably E is not the best word. Okay, what about the letter T? Well, same thing here. Well, I have a plain old Y by itself. Probably never have a word with a T, you know, just what T. So maybe replace all the Y's with A's. So now what we're going to do is to run the letter swap program here. And so that's another one here that we can just kind of copy paste this in. So let's go to our main PY file. We're going to leave secret message alone. Let's get rid of the frequency because we're not using that. And let's get the letter swapper. Let's Control A and Control C all that. Go to our main and just go through here. So if we look through the code here of the letter swapper, we get a initialized string input. So we don't want to enter that string. Let's enter it as a secret message. So the input string is going to be secret message. They're going to make a new string of the same thing and a temporary string of that same thing. All right, replace letter. We're going to go ahead and replace. So as long as we don't type in QQ for quit, we're going to go through and replace each letter. So let's go ahead and run this now. So we still have our encrypt, decrypt just at the beginning. I guess we could have got rid of that, but let's go ahead and see what this is. You know, let's decrypt, yada, yada, one. Okay. So next we're going to look at, let's go through it. And I think the best thing to do is to replace the letter Y with A. And as you can see here, here's the original string. And now we replaced every Y with A. Okay, the second most common letter was Q, right? And if I start looking at some Q's at the original, maybe we could replace all of the Q's with P, with like E maybe. So let's see. We're going to replace Q with E. We're going to hopefully start seeing something here. Now, as we go through here, this is almost like Wheel of Fortune. I'm kind of looking at this here. I wish I could make this a little bit larger. You know what I'm going to do? I'm just going to full screen this here. Like, if I look at the second letter here, I know I replaced Y with A. Do I have any Q's here? Q with E. Like, these vowels are here. Kind of weird. But if I try to think, okay, do I have a common three-letter word that starts with the letter A? And the first one I think about is and. So maybe I want to replace all the O's with N and the I's with D's and start seeing if I can start seeing anything else. All right, let's replace the O's with N's and then the I's with the D. All right, so let's see, I got an. Let's try to see. Okay, next we're going to try to see, you know, can we replace? So maybe go through your other common ones and go through. I'm going to give you guys some clues. This is a nursery rhyme. So I'm going to see if you guys, now this is the complete nursery rhyme and it took me a while. So let's try to think. Trying to find some other hill. So we have a couple ands in here. All right, should I give you another big clue? I'll give you another big clue. The first letter, we're going to place V with J. And maybe that will help you figure this out. So a couple clues on this one here. This is a nursery rhyme that you'll have to decode. And I mean, yep, and you just keep replacing letters. So this is not a shift anymore. This is just a replace. So every letter got replaced, switched around. None of them are in the right spot. All right, so good luck with this one. Once you guys figure this out, you guys are going to copy paste this over to here to get the encrypted message or type it out. Okay, actually no, into this spot here. We'll see how well that works. And if it messes up real bad, I might just give you guys some points. All right, I will see you guys next time. Hopefully you have some fun with this one. It will take some time, but it is a nursery rhyme. All right, you guys have a great day, and I will see you next time.